Hello YouTube and preppers, this is the Comms Prepper with a video about antennas. My bottom line up front is when selecting radio equipment for your preps, please don't forget about having the proper antenna. Specifically, are the antennas you're using matched for the frequencies that you're going to be operating on? On this slide here, I've selected the common radio services that are of interest to preppers. I have ham radio or amateur radio, the MURS service, FRS, GMRS, and for people who live near the coast or water or own boats, I even have marine listed down at the bottom. And at the very top, I have the frequency capabilities of the most common dual band radios out on the market today, which are very popular with preppers, like the Waxton or Ocean radios, Puxton radios, ICOM, Yaesu, Kenwood dual band radios. The frequencies listed at the top, or the coverage, is typical of all these radios. About 136 megahertz to 174 for VHF, and then 420 megahertz to 520 megahertz for UHF. And as you look below, you can see all the popular radio services of interest to preppers falls within these operating capabilities. Now, for the purposes of this slide, I'm only speaking about receive, not transmit, because transmitting carries with it a lot of regulatory requirements and not all equipment is approved for all radio services. But what's important for preppers to know is that while the radios have a capability 136 to 520, the antennas that come with those radios probably don't match that frequency capability, because frequency and antenna lengths are fixed. It's science. So lower frequencies have longer antennas and higher frequencies have shorter antennas, and you have to cut those antennas to match the frequency based on the wavelength of the frequency. So for example, if I were to cut an antenna for a full wavelength with a typical commercial radio antenna, for 136 megahertz the antenna would probably be around, depending on the vendor, 54 inches long. If I were to cut that same antenna for something up in UHF, like for 520 at the other end of the band, that antenna would be 12 inches long to make it resonant to match that frequency. Now, while in receive mode this isn't a big deal, when it comes to transmitting, it is a big deal. So here's a cutting chart for a typical commercial radio antenna that comes in the package, and I've highlighted the services that are of interest to preppers. I have a VHF column and a UHF column. So if you're looking at this chart, in the VHF column for ham radio, in the middle of that band, the antenna would be about 50 inches long. But if you look in the UHF column and look at the middle of the GMRS band, the antenna is about 15 inches long. So if you're running a dual band radio and swapping back and forth, you're going to have an antenna mismatch between antennas. So this can cause a problem in your radio's performance. So this, again, why do I care? You should care because of voltage standing wave ratio. Consider a drop of water landing in a puddle and the waves ripple out towards the end. If the antenna is a perfect match, the waves hit the shoreline and dissipate in the free space and they're radiated and you have communications. But if the antenna is not the right length, the waves ripple out, hit the shoreline, and bounce back towards the radio, and that creates heat, and over time that can degrade your radio or even destroy it. So you want to make sure your antennas are matched and cut for the frequencies you're going to be operating on. Now, some of the big vendors, like Motorola for example, on this chart, they have radios that cover these large bandwidths, like 136 to 174 in VHF. And in the example I have here, they're color coded, and you see there's a little red cap at the bottom where it hooks in. That's a wideband antenna, but performance is cut back to make it wideband. So to increase performance, Motorola sells other antennas with different color codes on the bottom, and you can see how they slice up the band to make those antennas more efficient. So if you had one of these Motorola XTS 3000 radios and you wanted to operate, let's say, in the MURS band, you would need a black cap antenna to screw onto the end of that radio for its most efficient performance. But with that very same radio, if you wanted to do amateur radio, you'd have to take that antenna off and screw on one with a yellow color code. onto the antenna. So that's how the big vendors address this issue. So just because your radio says it'll do 136 to 520, the antenna that came with it is not going to perform well or be efficient across all those bands, and over time could damage your radio. So how do you check for SWR? Well, here's a little chart I did. You get an external antenna adapter for your radio, a piece of RG58 50 ohm coax, hook it up to your watt meter, and then come out of your watt meter and hook it up to your antenna and transmit. And there's many different brands, makes and models out there for VSWR watt meters, and I put a couple of pictures below of some that are out there. But as you're transmitting, the meter will show your forward power and your reflected power. And what you're trying to achieve as you trim that antenna and cut it is to get that reflected power to as close to zero as possible, so you're getting all that transmitted power down the line and out. I did a slide here to demonstrate using my watt meter. On the left, I'm transmitting, it's almost 100 watts, and you can see the needle on the left hand side goes way up for the forward power, and then the needle on the right hand side that measures reflected power is sitting at 0. And that's what a good antenna looks like. That's a good match. The reading on the right is a bad match. So you see the reflected power is way up, and in this case it's around 12 watts. But like most other modern radios today, if the radio sees high reflected power, a poor antenna match, it cuts its power back to protect itself. So my 100 watt radio is now cut back to 50 watts to protect itself from the damage that's caused by reflected power coming back into the radio. And that's why having the right antenna is important for preppers, because if you think you have a 5 watt handheld but the antenna is not the correct match and you're transmitting and that radio will protect itself from reflected power, it could be cutting your power down to 1 watt and you're not getting the range that you should be getting. Plus, all power that's reflected is power that's not being radiated, so you're losing it. So again, this underscores why it's very important to have antennas that are cut for the specific frequencies you're going to be operating on to get the most efficiency out of those radios. And also, to give some thought about your operational tempo, your operational requirements. In a grid down or SHTF or roll situation, the walkie-talkies you have today could be replacing your cell phone. How often do you use your cell phone today? So if you have walkie-talkies today and the antenna is not a match, but you're only using them on the weekends, you're not seeing this effect of bad antennas. But if your operational tempo shoots up to where your radios are doing what your cell phones used to do, and you're using them all the time, this damage could happen more quickly. And during a grid down situation, if your radio fails, you can't go buy another one. So as preppers, we should do what the best we can to protect the equipment that we have to get us through a crisis or an emergency, because you may not be able to replace it. So the best way to protect your transmitters is to make sure they have the best antenna they can have that's matched for that frequency you're operating on. So the comms prepper's recommendations when it comes to antennas: confirm that your antennas match the bands of your radio and the frequencies you're going to operate. Invest in a VSWR watt meter in your bands you're going to operate. So if you're operating VHF and UHF, when you order a watt meter, make sure it's capable of doing VHF and UHF. And if you operate multiple radio services, amateur, merge, GMRS, etc., have more than one antenna. And you may have to put together a little antenna patch panel, or have them in your go bag to swap your antennas out. But the best way to protect your investment in your equipment is to make sure the transmitter in there has the right antenna for it for that operating frequency. And as always, thank you for watching and thank you for subscribing. This has been the Comms Prepper.